Welcome back to Learning Image Analysis. My name is Lawrence Small, and this is the start of Section 2, our Fast Track to Algorithm Development. Now the objectives for this section, first is to get you quickly producing simple algorithms. In some of our later sections, we'll get into a lot more detail to all the different steps that you can add to an algorithm, all the different manipulations you can do, all the different considerations you might have. But in this section, we just wanted to get the ball rolling. Get it so that you know, at least on a simple scale, the whole process of developing an algorithm and getting measurements out of it. And so this way, when we do move to the more advanced material, you have a better sort of broad working mental model of these algorithms. And that makes it easier to assimilate this more detailed information. And it also gets you quickly to producing results, especially if your particular applications aren't all that complicated. You don't want to have to sit through 5 or 6 more sections of detailed information, and this section here will get you quickly to a usable result. And I will say that we will be building algorithms during this section, but there are many ways of producing a good algorithm. So the one that we end up settling on for a particular lesson won't be the only way. And I'll give you all the images ahead of time so that you can play with them, you can experiment, and perhaps develop your own interesting, useful algorithms. So each lesson that we have will teach a particular concept, and the image will be one that really makes good use of that concept. And so most lessons will use a single image and result in a functional algorithm. There are a couple of exceptions, but those are rare. And also the lessons are progressive. We'll start with just building a very basic recipe, then we'll move to cleaning a segmentation, then we'll move to manipulating a segmentation to pull out additional information, all progressively building upon each other. So I do encourage you to start at the beginning if you can. So let's get to a brief overview of all the images that we'll do. Here is our first image of gold nanorods, and we'll be measuring the size of the nanorods, their shape, counting them. And our next image will be some two-layered nanoparticles. So particles with cores in the middle and shells around the outside. And from this image, we want to get particle size and the roundness of them. And we also want to get some information about about the composition of the particles. What's the percentage that's the core, say, and what's the thickness of the shell? This image is two-phase titanium. We have alpha phase, which is the dark material, and the beta phase, which is the bright material between them. And as you can probably imagine, the composition of the metal, the arrangement, the orientations, the sizes of these different phases all have a pretty significant impact on the material properties of the whole sample. So what we want to get from this image is a measurement of first phase fraction, and second lath thickness, the thickness of these individual alpha laths. And here we have a wound healing assay. So what the scientists will do is grow these cells, usually fibroblasts or some other migratory cell, until they're confluent, covering the entire dish, and then they take some sort of instrument and scrape a wound across the middle of these cells, so removing all these cells from the center. And then they watch over time as these migratory cells move into the center and close this wound. So over time, what they do is measure the width of this wound. And that's what we'll want to measure in this particular image. And here we have more cells. These ones are aggregated into colonies. So you have the individual cells here and the large colonies. And so the measurements that we want to get are an absolute count of the number of cells. We also want to get the colony size, the size of the individual colonies of cells, and then the percent confluency, how much of the image is occupied by colony. And here's our next image. We have some seeds here. And in this image, we're not going to generate a measurement. We're not going to get that far. Our particular goal for the lesson that we use this image in is simply to be able to segment these seeds while not segmenting these labels in this scale bar ruler here. So when you're working on this image, try to get a reasonable segmentation of the seeds while avoiding all these labels. And next we have some more titanium. This is bimodal alpha titanium. So we have these equiaxed alpha, these large dark alpha grains, and that's one phase. And then we have the secondary alpha. And the secondary alpha are these small, thin alpha laps. And just as in our previous titanium recipe, or excuse me, our previous titanium example, the composition of the material, how much is primary, how much is secondary, has a pretty big impact on the structural properties of the metal. So we'll be wanting to get first the percent alpha, total alpha, versus the beta. Beta is this bright material in between. We want to get an alpha grain size, the size of these large grains. And then a percentage, primary alpha versus the percent secondary alpha. And our last image is a fluorescent-labelled neuron-like cell. So the cell has its cell body here in the center, and the neurites extending out. And the cell itself is labeled with 3 different stains. We have the cytoskeleton, some neurotubules stained in green. And this defines what is cell and what isn't. Then we have the nucleus in blue in the center, and the mitochondria of the cell stained in red. And we want to characterize the amount of mitochondria that are in the neurites versus in the cell body. So as a percentage, how much is in the neurites, how much is in the cell body. So our next lesson, it will be our first recipe building lesson. We'll just cover building a simple, basic recipe. Okay, so I will see you then.